Hello, welcome to our topical solution series for IGCSE at Maths 0606 paper. In this video, the topic we are going to focus on is factors and polynomials. The questions we have chosen to solve in this video is taken from May-June 2011 or summer 2011 from paper 2-1. Let's go to the question. Here we go. Question number 5, the expression x cubed plus 8x squared plus px minus 25 leaves a remainder of r when divided by x minus 1 and a remainder of negative r when divided by x plus 2. Section 1, find the value of p. Okay, before we proceed to solving this question, let's take a quick review of what is the key ideas involved in this topic. Well, we only have two main things to focus on. They are the factor theorem and the remainder theorem. And what are each of them is? Well, the factor theorem just tells us the polynomial that was given to us, and then if they have a factor, and the factor is always a binomial. For example, it can be given to you as x plus 5, or it can be in 2x minus 3 and so on. Well, those are the factor. And then when it is in factor theorem, it just means that the polynomial, if you divide it with the factor, you will have a complete division that leaves no remainder. And in the factor theorem, what it helps us is that from the factor, the binomial, you can draw out the x value. And if it is a factor, then the x value is called the root. And that is something that we're going to take out the root, and we're going to take the x value, substitute into all the places where there is x appear in the polynomial. And once after the substitution, the factor theorem tells us that the expression will equal to 0. That's all about factor theorem. Let's move on to a quick revision about remainder theorem. Well, it just tells us the polynomial being divided by a divisor. And again, the divisor usually is a binomial. For example, x plus 1 or 2x minus 7. And what we do is that if you take the polynomial, divide it with the divisor, the binomial, you're going to have at the end some form of a remainder. And in the remainder theorem, it just tells us from the divisor, you can draw out the value of x. And when you take the value of x, substitute into all the places where x appear, you're going to equate it to the remainder value. And that's it. That is a quick revision on a factor theorem and also the remainder theorem. Well, let's go and get more experience by solving this question. Yes, now it was given to us the assignment to find the value of p. Well, the clue was given and I have highlighted the key thing for you to look at. Well, from the sentence, they say the expression, it is a polynomial and this is a cubic, and they say leaves a remainder. Well, this word gives you a pointer that this will invoke remainder theorem. And that's how we're going to start with that. Now, when divided by x minus 2, this is the binomial that I talk about. And because this leaves a remainder, so this is what we call them the divisor. And then from the x minus 1, we draw out its x value. And the x value is always having the opposite sign. Well, how do we get that? It's actually when you take the divisor equals to 0, and therefore that's how you're going to get the new plus 1 both sides. That's how you get the positive 1. And that's how the background things that's happening in order to draw out the x value. The same thing works with a factor and its root. Now you have obtained the x equals to 1. Then now what we do is you take this x value, substitute in all the places where the x appear. And we have done just that. So 1 cubed plus 8, 1 square plus b times 1 minus 25, and they say equals to a remainder. Well, because it doesn't give us what is the remainder, so we come up with a notation, capital R, just simply to represent the remainder when the polynomial is divided by x minus 1. Well, we have done the translating the English information into mathematical notation. Now we proceed with the next statement when it says, and a remainder of negative r when it is divided by x plus 2. We do the same thing from divisor x plus 2. We draw out the x value. Yes, exactly what we do, and therefore we get x equals to negative 2. Yeah, so now what we do, we're just going to take the negative 2 value, substitute into all these x places. Yeah, therefore this is what we have done, shown here, negative 2 cubed plus 8, negative 2 squared plus b to the x now is substituted with negative 2, and minus 25 just copy down and equal, this is the remainder was given to us, and this also notate that as negative r. So that's what we put in there as negative r. Now what we do, as what we have done just now with the after substitution done, you just expand that and simplify and gather the like term. Now you have got for yourself the simplified version, that you have got that as 1 plus 8 plus p minus 25 equals r. So simplify into p minus 16 equals to r. And after what we have simplified here, that we get that as negative 8 plus 32 minus 2p minus 25 equals negative r. Okay, now what we're going to do is we're going to fulfill the criteria given to us. Now you have the r as p negative 16. So we're just going to put that into this equation. Well, this is what we take the first equation and substitute it in the second equation. That's how we get that. And from there, you can move all the p terms to the left-hand side, and you gather all the constant to the right-hand side, and such that you solve for p and you arrive at your final destination or answer, that p equals to negative 17. There you go. You have complete your first section. Now, section 2. Hence, find the remainder when the expression is divided by x plus 3. Okay, now with the word hence, it's just giving you the clue that you're going to use back the answer that you get from part 1 and use it in your section 2. Therefore, with the p-value that you get as negative 17, here's the completed polynomial that you have got. The one question given is with the p unknown. Now you have solved the p and you substitute the p-value, and that you get a completed polynomial. Now, use the remainder theorem to find the remainder. How do we go about that? The same thing with the divisor x plus 3. It was mentioned here, x plus 3. You draw out the x value, which is x equals to -3. And you take -3. You do the same thing as what you have done previously. Substitute into all the places that x appear. So now you got -3 cubed plus 8, -3 squared, minus 17 multiply, -3, copy down, minus 25, and it's supposed to equal to the remainder. And isn't that the question asked you to look for? Exactly. So what you do is, you just simplify all this thing and all the way until you gather all the like terms, and that tells you 71 is the remainder. And therefore, what we conclude here is that, as we go, remainder equals to 71. With that, we have successfully solved both sections of this question. With the marks allocated 4 plus 2, 6 marks, you have successfully acquired for yourself the total 6 marks. Congratulations, what a great journey. All right, so now with that, we called it to the end of this video, and I'm looking forward to meet up with you again in the next video. And before we say goodbye, as usual, my favorite wish for you is happy learning always, and looking forward to see you. Bye-bye.